Today we're looking at the ratios and proportionality standards 1 through 3, and most of them come down to a few key concepts. One is unit rate, one is an equivalent ratio, and then one is proportional relationships. So those three are the big things that if you understand and you're able to calculate, you should be able to solve a lot of the questions on the EOG. Now, some of these are calculator inactive. Most of those are going to be dealing with fractions. So reviewing about how to add and subtract and divide and multiply fractions is where we're going to start. Remember that when you add fractions, you need a common denominator. So I can't just go 1/5 plus 1/4 and just add straight across, because I need the sizes of my pieces to be the same before I can compare the number of pieces. Now, if it's ones like this where probably the closest multiple is going to be 20, you can multiply this by 5 and multiply this by 4, which would then give me, instead of 1/5, 4/20, right? Because 4 times 5 is 20. And this would be 5/20. And then I can add straight across. Now, remember, my number of pieces doesn't change. That's always going to be 20, but I can add across to 9/20. And then I can see if that simplifies. I don't believe it does. So I would leave it like that. Subtracting works the same way. So when you add or subtract pieces, it's just like cutting up your pieces of the pie, right? And you are adding or you are taking away those pieces, but they have to be the same size in order to add and subtract them. Now, when we deal with multiplying and dividing fractions, let's say it's 1/4 times 1/5. Now, I don't need a common denominator, because if I multiply them, I'm going to get a much bigger number on the bottom, meaning I'm going to have, if I have 1/4 of something cut into 1/5 copies, it means my pieces are going to get a lot smaller. And so I'm going to multiply straight across. 1 times 1 is 1, 4 times 5 is 20. So if I cut 1/4 into fifths, I'm going to get 1/20. Now, it's sort of the opposite with dividing. So if I'm dividing fractions, if I'm figuring out how many fifths there are in 1/4, I'm going to flip it, and then I'm going to multiply. So this is your keep, change, flip. So I get 5/4, which would simplify down to 1 1/4. So again, I don't need the pieces to be the same. When I divide fractions, you're typically going to get a bigger number, because you're cutting that original piece into pieces and saying how many of them are there. So when you multiply fractions, you're going to get a smaller number typically. When you divide fractions, you're going to get a bigger number. So that's just key operations. Make sure you know how to do it. It's good to practice, because where people make mistakes on a lot of these problems is with the fractions. Okay. So let's talk about unit rate and equivalent ratios together. A unit rate is a special kind of rate where one of the quantities is 1. Now, a unit rate is also an equivalent ratio, because let's say I tell you that there are $3.60 will buy you 8 pounds of apples, but I want to know how much for 1 pound of apples. So I've given you a ratio here of 360 to 8 pounds. And I'm asking you to find what 1 pound is. So there are lots of ways to do this. The simplest way is just to divide. So you divide 360 into 8, you're going to get 0.45. You can kind of check that mental math, about 50 cents per pound. That seems about right. So when you have these two equivalent ratios, you can also write them. So that may be familiar to you as looking like what we do with the butterfly method when you're comparing equivalent ratios. You know to do that by putting an X on the part you don't know and then cross multiplying. We'll talk a little bit about that later. But a unit rate, again, is a special kind of equivalent ratio where one of them, the quantity, is 1. Now, when we have unit rates, it's always in 2 different units. So up here we have dollars, down here we have number of apples. Let's look at equivalent ratios now. So there are lots of different ways to deal with equivalent ratios. One way you can do it is to do what's called scale in tandem. And you can do this with something like a double number line, although you could also do it with like a ratio table. So let's say, this is one of the questions that you've seen before. Let's say you can drive for 1/4 mile on 1/64th gallon of gas. The question asks you how far can you go in a full gallon of gas? So one thing you can do with this is you can double them each time. So I can go up to 1/2. So I'm doubling that. And then I'm going to double this up to 2/64ths. Then I'm going to double it again up to 1. That would be 4/64ths. So see how every time I'm doubling it on both sides. And then I'm going to double it again up to 2, which would be 8/64ths. Now I can keep going like that. With a question like this where I'm trying to get to 64/64ths, that's going to take a really long time. So in questions like this, you can say, all right, well, I want to know how many miles per gallon. So there's 1/4 mile per 1/64ths gallon. So in this case, keep, change, flip comes in handy. I'm going to turn and do 64 over 1, which gives me 64 over 4, which simplifies down to 16. Now, can I get there by scaling up in tandem? Yes. But if you're working with really small fractions, scaling in tandem isn't always the best solution. Sometimes the best thing is to read it as, well, it's miles per gallon. Per means divide. So I know I'm going to need to do miles 1/4 divided by gallons to figure out how many miles per gallon. A double number line works like that, where you can move up additively, or I recommend doubling and halving. So doubling until you get closer, and then figuring out smaller increments you can go up in. You can do the same with a ratio table where you have same value. So it'd be like 1/64th there and 1/4, 2/64ths and 1/2. So you can see it's going up in tandem. And tandem just means side by side. Scaling, remember scale factor, I'm sure. Scaling means to go up or to go down. Tandem means side by side or proportionally. Now, you can also use, especially for percentage questions, benchmark fractions and benchmark percentages. So if you think about like the bear builder question, if you want to know what you have 100% is equal to 20. I can take a 0 off each of those and go down to 10%. So I know 10% is 2. I can take another 0 off by moving the decimal place and get 0.2. Now, almost every question you can get there with tens, hundreds, and ones. It may be a little trickier, but knowing your benchmark fractions, knowing that I just take a decimal off, I move a decimal place, and it gets me those percentages makes it a whole lot easier. And then if I've got 1, remember that's a unit rate. So I can just take that 1% and I can multiply it by whatever percentage I'm looking for. Let's say it's 38, and it'll give me exactly what that is. Now I can also do it additively, where I take 10% times 3 and 1% times 8, or even 10% times 4 and get 40 and then subtract 2%. You can do it any of those ways, but knowing how to get 10% and 1%, so benchmark fractions or percentages, is really, really helpful. The other way you can do this is by using cross multiplication. Now, you can do that because they are equivalent ratios. So when it's a percentage, you always have 100 on the bottom, even if you're looking for more than 100% on the top. But it's always out of 100. And the reason this works here is because percentage is a ratio, something out of 100. So if I want to know out of 20 what 120% is, I can cross multiply, and then I can find my answer, which in this case would be 24. But the question really is, why does this work? Let's see if we can figure it out using algebra. When we are dealing with an equivalent ratio here, right, we have the equal sign in the middle, which means that these are balanced. This works because if we know 3 of the quantities, we can find the other one. So think about how we deal with equations. If I want to get rid of the division of 100, I need to multiply this side by 100. So I'm doing that to get rid of that 100 because I want to get rid of everything in the denominator. Now, if I do it to this side, I also have to do it to this side. Okay. So go ahead and simplify that step. I've got 100 over 1 times x over 20 equals 120. Now, my other problem, though, is I have a 20 in the denominator here. So I'm going to go ahead and combine those and get 100x over 20. I want to get rid of that 20. Well, how do I undo division? By multiplication. But if I do it to this side, I got to do it to this side too. So I've got 20 over 1. Now I'm putting the 1 there just so you can see that these cancel each other out, because 100 divided by 100 is 1, right? So we get rid of those. Same thing, 20 cancels out, which gives me 100x. So now if I simplify this, I've got 100x equals 120 times 20. So if what is that, 2400? I think that's right. Doing this in my head. So I've got 100x equals 2400. Now I want x by itself. And to isolate the variable, we've got to divide by the coefficient. So I've got divided by 100. I know it's really hard to see down there. There you go. And to divide by 100, I just take my zeros off, which gives me x equals 24. So why does this work? Because what you're doing is when you cross multiply, you're just simplifying a step. Instead of saying multiply by 100, multiply by 100, you're just pretending that all you're doing is multiplying by 100 and multiplying by 20. But essentially what you're doing is using the rules of algebra that you already know. When we think about unit rates too, we can think about the same thing about cross multiplication. So go back to our apples, right? We had the 360 divided by 8 equals x over 1. Same thing. If I multiply this by 8, I'm getting rid of that 8, multiply this by 8, and then get rid of the 1 by multiplying by 1, and that gives me my unit rate. So it's the same thing as the butterfly method, where you were taught to do that to compare equivalent ratios to see if they're the same, but you're just using the steps of algebra to figure out why it works. So one other thing that you'll see on the RP1 standards is asking you questions like, okay, if 1/20th of this set has this much, and 5% has this much, and then 4 total has this much, who has the most or who has the least? And it'll say out of like 25. So it's going to ask you to find those and compare them. So the question is, how do you do that? How do you find 1/20th of 25? Well, can't you use the butterfly method there too? 1/20th out of 25? Can't you do that? Or 5 out of 100 equals something out of 25? Or here you got 4 out of 25. Now, I don't need to put that in anything else. I can just divide and get a decimal, and then I should be able to compare them. Lots of strategies for dealing with this with equivalent ratios. All right, so in RP2, what you're doing is you're thinking about proportional relationships. So we've talked about it with unit rates and equivalent ratios. Those are proportional because they vary directly with one another. When one goes up, the other goes up. When one goes down, the other goes down. So they stay in proportion with each other. Now, a big part of this standard is dealing with charts and graphs and tables. You're going to see proportional relationships as starting at 0, 0, right? 0x, 0y, and then moving up in a straight line. Okay, so this is a proportional relationship. Always 0, 0 is where it starts, and it moves up in a straight line. If you have something that's like a curved line, that's not proportional. Okay, so when you see a graph, we're talking about the x-axis and the y-axis. I know Ms. Smith says that you have to walk before you climb. So x comes first, then y. And let's say it's just, let's see, I'm going to do 2, 3, 4, 5, and then here 5, 10, 15, etc. Okay, so point there, I have a point there, I have a point there. So now the question may be something like, what does pair 3, 10 mean? And it'll ask you to look at the graph and determine that. So first you find the point. Remember, the first one is the x term, and the second one is the y term. So I go to 3, and then I go up to 10 and find that point. Well, let's say this one is hours, and this one is miles. So what would it be? It would be 3 hours for traveling 10 miles. So you're going to see quite a few like that. You're also going to see the same thing in charts or in tables, and it'll ask you to determine whether it's proportional or to interpret the meaning of one of the points on the line or in the table. Now, something else you're going to see as part of RP2 is equations, where it'll give you some kind of chart. Usually it will not give you the unit rate. It'll give you like what for 2 of something or 3 of something. So let's just say 10, 15, and it'll say, write an equation, or which equation best models this relationship. Well, what it wants you to do is to first go down to the unit rate. So 2 divided by 10, that would be 5. So the unit rate would be 1 in 5. And then it'll say write an equation. So if we go back to, say, the apples problem, where it was 360 for 8 pounds, then what do I do with that when I have my 0.45 and my 1 pound? How do I write an equation? Which is the x and which is the y? Well, let's just do it this way. X equals 0.45y. Now, this right here, the unit rate is also called the constant of proportionality, right? Because it doesn't change, so it's a constant, and it's proportional. So constant of proportionality. And then what you need to do is decide which term is the x and which term is the y. Well, what times 0.45 is going to give me x? If I put 8 in here and I put 360 in here, will that give me a true statement? Is 8 times 0.45 360? Yeah, but if I did it the opposite way and I had 8 here, and I put 3.6 here, I'm going to end up with something much bigger. So what you want to do is you want to take what's in the chart, find the easiest value to plug in and make sure it's correct. So you're going to get a lot of questions like that say, make an equation from these terms, take it down first to the unit rate, and then check it with the other terms in the table so that you're sure you know that you did it correctly. Okay. So you're going to see those charts, you're going to see formulas, and you're going to see graphs. In RP.3, you're going to see a lot of special terms. And you may remember these as we go over them, but these are all dealing with questions about percentages. So you're going to see things about tax, tip, markup, commission, pay or percent increase, and then pay or percent decrease. All of those, as long as you know how to find percentages, you can find them. There's just slightly different ways of adding them into the total. So let's look at a couple of those questions. Okay, so one type of question you're going to get is where it'll give you the price. Let's say something is $29.99 and the discount is 20% and then has an 8% tax rate. Now, most of these questions are going to say approximate. So feel free to round to make your life easier. So going with 30 and then finding a 20% discount. Well, 20% is double 10. So if I find 10%, which would be $3 is 10%, then $6 would be 20%. So I have a $30 shirt with a $6 discount, gives me $24 before tax. You always take the discount before the tax because the tax is on the final price you're paying. You wouldn't want to pay tax on the original price because then you pay more. So then I need to find 8% of 24. Now I know 10% is 2.4. So if this is multiple choice, I might just take about $2.50 off this and then see if there's an answer that looks pretty close to that. You can find it more precisely by multiplying by 0.08 and then taking that off. Okay, so that's price, discount, and tax. Now you're also going to see it as this person paid this much money for this, like this dish cost this much, plus this person's dish cost this much, plus there's tax. And then they want to pay a 20% tip. But so you would add up you'd add up everything, all the costs, and then you'd figure out the tip, and the tax would be based on all of the things added up, and so would the tip. Now, if it says tip on top of the taxed price, then it wants you to add it all up, add the tax, and then do the tip last. So you'd add them all up, figure out the, let's say, 7% tax rate, and then find 20% of that total, and then add that on to the end. Remember, they're going to try and trick you here. So let's say you add it all up correctly, you added your tax up, and then you find what 20% is. And there's an answer choice that is just that figure, the 20%, not the total plus the 20% tip. So remember, you have to add that tip on, and that's what you're going to want to choose. Don't get fooled by here's the value of the 20% tip. You make sure you add that back on. All right, commission. You guys really struggled with commission questions when we did this. So commission, you have a total sales, and then you have a rate of commission, which is usually like, let's say 10% or 8% or 5%. And you have to find what that is of the total sales. So a commission is basically how much did you sell? I'm going to give you a percentage of that. So if you sold $2,000 and you get a 10% commission, you would make $200. And then it's going to give you a salary. And your salary is your base salary plus your commission. And that's what you're looking for. And then it might say, how much would they make a month? So then you divide by 12. So commission is a percentage of total sales added to a base salary, because almost no one can live on just commission. They usually would make a salary, let's say it's $2,000 per month, plus whatever they make in commission. So you'd get $2,200 in that case. All right, and then you have markup. So markup is the amount the stores add to a price in order to make a profit. So if you have a $20 shirt and let's say a 120% markup, you would find what 120% of 20 is, and then figure out how much that would be. So if I want 100% of 20, that would be 20. And then if I want another 20%, I can take my 10% and my 10% and add that and be 24. So a shirt that cost the store $20 is selling for $24. Now it might also ask you about percent increase. So what is that percent increase? Maybe it doesn't tell you that. It says the store bought it for 20 and they sold it for 24. What's the percent increase? Well, it went up $4 out of 20. What is that out of 100? You can use cross multiplication to figure that out. So those are all the different kinds of questions you're going to get. Make sure you're paying attention and you're double checking your work. You can sometimes go back and use a calculator afterwards. I like to calculate it by hand and then go back with a calculator and just double check that you did it correctly.